We have worked with the topic superconductors, and we will talk a bit about what it is and what we use as a superconductor for. We have an agenda in which we will talk about the following topics: state for discovery, what is a superconductor, different superconductors, the Meissner effect, usefulness for a superconductor. Date for discovery. The first superconductor was discovered in the year 1911 by the Dutch physicist H. Kamerlingh Onnes. He used the mercury, and his experiment was that he cooled mercury down to a very low temperature, just around 4.2 Kelvin. In Celsius that corresponds to about minus 269, and at that point the resistance in the mercury fell to 0 ohm. This means that the absolute zero for mercury is around 4.2 Kelvin. That was the first time a material's absolute zero was discovered. What is a superconductor? A superconductor is when a material is cooled down to its absolute zero, also called Tc. The Tc is more precisely called the critical temperature. That is when the material's lead ability goes from normal to excellent. No resistance. The Tc for different materials vary from material to material. The magnetic field around a conductor is called the magnetic flux density, Bc. When the field is bigger than the Bc, the material's superconductivity cracks. The higher Bc, the smaller Tc, so if the Bc is high, the Tc is very low. All non-magnetic metals are superconductors at the Tc. Alloys between these are also superconductors. A superconductor does not allow magnetic fields inside it. There is a maximum for how much power you can put into a superconductor. It depends on how cold it is. The colder, the more power does it allow. That is also called the critical current, Jc. That is also different from material to material. Different superconductors. We have some different superconductors. The first two are the high temperature conductors and the low temperature conductors. The high temperature conductors have a higher Tc, which means that they does not have to be as cooled down as other superconductors. The definition is that the Tc is higher than 30 Kelvin, 230 Celsius. They were discovered in 1986. The low temperature conductors have a low Tc and demands a bit more to use because you have to cool them way more down. They need to be cooled down by liquid helium, which is very expensive and difficult to work with. Then we have type 1 and 2. Type 1 is the main used and also the first to be discovered. That is often clean materials like tin. That Tc is often close to the absolute zero. It is impossible for a magnetic field to penetrate into a type 1. The second type is type 2. That is often made from La, and they are often low temperature conductors because they have a very low Tc.
The Meissner effect. The fact that a magnet can levitate over a superconductor with its own magnetic field is called Meissner effect. This effect can, for example, make that a train can remain suspended over the rails so that there is no mechanical resistance. What happens is that the superconductor produces an opposing magnetic field to compensate for the magnetic field from the magnet. This is called the Meissner effect. Usefulness for a superconductor. As mentioned before, could a train float with the Meissner effect over the rails? This is called magnetic levitation, and are used in some places in Japan and China, and has a speed of up to 500 kilometers. And it is possible to send a large current through a wire without it melting, and then you can cut off the two ends of the wire, and the current will flow back and forth to infinity without a power waste. They are also used in superconduction electromagnetics, for example in particle accelerators. This requires strong magnetic fields. Also, the alloy of M, Be and Ti, called niobium titanium, and it is widely used as a leader in powerful electromagnets in such hospitals' MRI scanners.